In the second tutorial, we will go backwards and write equations of quadratic functions given a graph. So let's flip over to example 3 and 4. This time we're going backwards. I'm giving you the graph of our function. I want you to write the equation. And I'd like you to write the equation in vertex form, which will not be too difficult since that's the only form that we know so far. So our vertex form is y equals a times x minus h quantity squared plus k. I encourage you to write that each time just to practice writing the form. We need to find a, we need to find h, we need to find k, plug those numbers in, and we'll be finished. Let's start with h and k. So the h and k come from the vertex, and I can see that my vertex is right here. I'll put a little box there. My vertex is, let's count out that ordered pair, 1, 2, 3, 4, down 2, so 4, negative 2. So I've basically done 2/3 of the work already. I have h, I have k, so I can plug those in. Y equals, I'm going to leave a spot for a, there's going to be a number that goes here, so my parentheses x minus h. H is 4, so this is x minus 4. Don't forget the squared, that's what makes it a quadratic, and then plus k. So k is a negative 2. I could put plus negative 2, or I could simply put minus 2. So we need to go and figure out what a is now. Now I know that a is positive because our graph is opening upward, so I need to figure out what we have going on here. Really the easiest thing to do is just, once you know what your vertex is, count to the right 1 unit and see how much you go up or down, because whatever that distance is will be the value of a. So when I go to the right one, it looks like I'm going up 1/2. That must be the value of a. A is 1/2. I can confirm that if I want to. If I go 2 units to the right, I would normally be going up 4. But in this case, since a is 1/2, I'm only going up 2, half as much. You could keep going and just check it if you want to. 1, 2, 3 to the right, I normally would be going up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, I'm only going up half as much. Here's half, and here's the other half. So it is exactly that a is 1/2. I'll put the 1/2 here, I will smile, and I will be finished. So find h, find k from your vertex, and then just count 1 unit to the right and see where your output is, because that will be the value of a. It is that simple. Let's look at our last example. Let's find the vertex first. Here it is. Right here at the top of our parabola. I'll put the vertex down here. That is -1 and then 1, 2, 3, 4, 5, 6 up. So -1, 6. That gives us h. That gives us k. So I'm going to practice writing y equals a times x minus h quantity squared plus k. It's always good to practice writing it. And then I will substitute in. I'll put y equals, let's leave a spot for the value of a. X minus h. If h is -1, when I do x minus -1, it makes a positive 1. X plus 1. Don't forget your squared. Plus k is plus 6. Okay, so now we need to go and figure out what's going to go here. Now I do know that a is negative because we are opening downward. That's helpful. Let's see exactly what number it is. When I count to the right 1 unit from my vertex, it looks like I'm going down 1. And going down 1 must mean that a is -1. Let's confirm that. If a is -1, then these would be our regular outputs just turned upside down because of the negative. So let's count 2. If I count 2 from the vertex, 1, 2, I should be going down 4. 1, 2, 3, 4. Yep, looks like it. When I count 3, 1, 2, 3, I should be going down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So a is indeed a -1. So I could put -1 right here, or really the best way is just to put the negative sign. And I've written that equation. So going backwards is really not that difficult. Find the vertex, that gives you h and k, plug those in, and then just count 1 unit to the right from your vertex and see what value you're outputting. And that will be your value of a. Plug that in, do not forget your squared, and you'll be good to go. That was a quick one. I'll see you in class to practice going backwards with that. Standing ovation. I appreciate that. See you in class.